Okay, so let's start off as people still join. We will anyway start with some introduction and giving the context to what we would be discussing in this session. This would be more like on IAM, as I mentioned, identity and access management, and typically it's the backbone of what you are trying to do in AWS. So how two services interact with each other. Before they interact, they need to get permission from each other, right? Whether whether one who is trying to access the other service has access to that service or not, and whether the service 2 is allowing service 1, something on those lines. So that's what we are going to discuss. If you understand IAM, as I mentioned, somebody who is who attended my last session on IAM would know that what I mentioned generally is that IAM comprises 40 to 50% of the entire AWS cloud computing. So if you understand how these access permissions, policies, roles work, then more or less 50% you are done with AWS. Okay, remaining 50% is just knowledge about the different services. Okay, what is SNS? SNS is a notification service, and what are the features, what it is best used for, and so on and so forth. Okay, so which gives this a lot of importance, this particular session, because if we say 50% itself is going to be understood in one session, then you can imagine the importance of the topic, right? It's a little bit of a confusing topic as well for a few folks when a lot of things are being taught at the same time and things get confusing and people get overwhelmed, which is what we will not try to do today. So it's going to be more easier session. With that said, let me quickly share my screen. Okay, so we will start off. Okay, so as I mentioned, IAM, we will discuss various topics like IAM user, groups, roles, policies, service to service permissions, common scenarios, etc. And by the way, I am certified AWS developer and solutions architect. I used to work in JP Morgan as VP engineering, prior to this, and I possess more than 18 years of industry experience, working in various companies. Okay, that's about my introduction. So we will move on to, is it coming like this? Okay, so very simple question which somebody would ask is, why do you actually need IAM when things can work as it is? What's the use? Well, IAM is needed for you to get, for one service to get permission from other service, but otherwise any service can access any other service, which becomes a very dangerous thing from a security point of view. So there are n number of different services in AWS, and each service has its own task which it is doing. For example, EC2, Fargate, ECS, EKS, Lambda, all these are compute services. So you run code in these services. Similarly, you have database related services, right, which could be DynamoDB as a NoSQL or RDS as a RDBMS, and so on and so forth. And similarly, you have services for notification, for one service for queuing, etc., right? So that's why it becomes important for us to properly understand how one service can access another service. That's what would form the backbone of when you're trying to architect or design systems in AWS. The problem mostly lies here only. You just don't get the access and you don't understand why the access is not happening. Okay, and that's why fundamentals of IAM needs to be very very much understood, because most of the problems lies here. You have a lambda at one end, that. Okay, but it's not accessible. Okay, that's what a lot of times you get these errors when you're trying to do these things real time. Okay, so that's one thing. Can you see which page you are able to see? Page 2, right? Can somebody just put in the chat what are you seeing right now? There is some gap in terms of, yes, okay, because these tools keep on changing, and sometimes navigating inside of Zoom becomes a challenge because there are so many options available, right? So but yeah, I mean, we will I think now it should be fine. Why IAM slide? Yes, got it. Okay, and the idea is that there are two things when we start off IAM. Generally, we start off with authentication and authorization. So the different IAM entities which comprise this would be IAM user, group, or role. Okay, we will come to each one of them. We will discuss each one of them in detail. But think right now, you just remember that for authentication, you require these three identities, and for authorization, which defines the permissions, which could be attached to any of these three entities, is related to authorization. Okay, so you would have resource based policies. So policies is what comprises authorization. IAM entities comprises authentication, and these two concepts comprise your IAM, identity and access management. Okay, and in policy you would have different policy types. We will discuss all those types, which are resource based, identity based, AWS managed, customer managed, etc. Okay, and if you are able to see the diagram at the bottom, you see IAM, one side is authentication, the three entities we have put, and then you have the authorization, which comprises your IAM policy, different IAM policies. Okay, we will try to learn all of these policies one by one. Okay, okay. Okay, let's move on. So what is it that we are trying to do in terms of IAM groups? Let's look at first the IAM entities are three, as I mentioned: user, group, and role policy. IAM role is something like a person. It's defined for a person, for a human being. Okay, IAM user is a human being. IAM group would be a group of these users. Okay, and IAM role is something assumed by the AWS resources like Lambda, EC2, etc. Okay, so, and then as I mentioned, policy would be a policy associated to an IAM identity or AWS resource. So that's how IAM policies work. Okay, so if you see the diagram, you will have IAM policies which could be attached to any of the three, and then the policies also, and basically policies getting attached directly to the resources as well. Okay, that's also possible. Now coming to the first entity, which is the IAM users. As I mentioned, it is associated to a person. It would have access via CLI, console, So you can have a username password when you're logging into AWS account. You would have a root user, correct? So that becomes a IAM user only. And then programmatically, if you have to use that user, you can have access key ID and secret access key available from AWS console, which you can put in your program for you to use it programmatically if you don't want to use your username password in the code. Okay, that's also possible. Moving towards IAM group. IAM group is nothing but a collection of IAM users. You cannot have one group inside another group, so that nesting of groups is not allowed. It's more simpler. A group is just a collection of users. What generally happens is you create a group, you attach policies inside of that group, and then you keep on adding users to the group. Automatically the users inherit all the policies and the permissions associated to those policies. Okay, that's how generally it happens. And if we look at the different examples, you have let me do it in single page form. Yes, this is better. So what you have is this we already saw. Then let's look at a few examples of all the two all the different entities we talked about. So let's say if a new user wants to access CloudFormation template. Okay, so the idea is that in AWS always there is a concept of granting least privilege. So if something is allowed, then only it's allowed. If there is nothing you are putting, then it is by default denied. Okay, please remember this. It starts with a deny. It's an explicit deny. It's a implicit deny unless you explicitly allow it. Okay, so by default it's a deny inside any of the permissions you talk about in AWS. That's the first point. Let's say you have a Lambda, and that Lambda, you have some code which is running in that Lambda. Okay, you want to get some data from a DynamoDB, which is a NoSQL DB in AWS. What would need to happen is AWS Lambda would need to assume a what is called as an execution role in Lambda, and then that role needs to have the permission to read DynamoDB. Okay, just a few examples we are taking before we move in detail to understand all these different concepts. Okay, and let's say another example. I'll just move on after this example. S3 plus IAM. Now what would happen is, let's say you have a IAM user, and that user is trying to access S3 objects and buckets. So that user needs to have access permissions for it to access that bucket. So that's how it would be able to access S3. Okay, and in the same account you may not want to have a bucket policy associated to S3 for this user to access S3, but user should have a policy statement saying this user can access this particular S3 bucket and on this particular S3 bucket, and with different actions, which could be get, put, update, whatever. Okay, okay, let's quickly look at, as I mentioned, different policies could be there. So you can have just let me quickly check what is the order in which things are coming up. Okay, which is fine. Users, groups, examples, which is fine. Yes, standalone policy. Okay, great. Okay, let's discuss the different policies which, as we mentioned, there could be different policies which could be associated. One is a AWS managed policy versus customer managed policy. Now, as the name suggests, in this kind of a policy, you will have this maintained and managed by AWS. Okay, there are a lot of AWS managed policies already available for some popular tasks, which are like generally which keep on happening for all accounts. Okay, so AWS has already created those policies, so you need not create them from scratch. You will create policies only for your particular use case. Otherwise, if it's a very similar use case of what they have put, you can use those policies directly. And then you will have customer managed policies, whatever is respect to your use case. That's typically the difference between the two policies. Standalone and inline, it's a terminology which keeps on coming, so it's always better to understand what is the meaning and difference between the two. Very simple difference, there is nothing much here. So standalone is more, can be attached to multiple identities, and so it persists even when an associated IAM identity is deleted. By identity I mean any of the three identities we talked about. While inline has a strict one-to-one relation to its associated IAM identity. Okay, so it will also get deleted as the identity gets deleted. That's the basic difference. It has a one-to-one relationship. Here it can be attached to multiple identities, so even if one identity goes away, it still persists, the standalone one. Okay, and now IAM policy types by the entity it attaches to. Okay, so there are two types. This particular type of distinguishing different policy types or understanding different policy types is is very important. Identity based and resource based. Now, identity based could be standalone and inline both. It can be both AWS or customer managed, while inline, as we know, has a strict one-to-one relationship, and policy will be deleted with the identity. But the identity based policies, which is user group or role related, could be any of the two. Resource based policies are more always inline policies. They are associated to a specific resource, like S3 bucket policy, SQS access policy, trust policy, etc. So these are all policies associated to a resource or a service. Okay, and if you look at the diagram below, identity based policies could be standalone, inline, one-to-one, attached to multiple roles, groups, users, etc. Resource based, attached directly to the resources. Okay, and then you have other types like permission boundaries, organization service control policies, SCPs, S3 access control lists, session policies, etc., which we will quickly touch today as well. Okay, let's quickly check what is it that we mean by permission boundaries. Okay, so permission boundaries generally sets the maximum permissions an identity based policy can grant. Okay, so just think of it in that way. Service control policies are more on the org level, so you can have IAM policies. So IAM policies actually can't restrict AWS account root user, but an SAP can. So it works on the organization level or on the account level. Okay, remember, service control policy. S3 access control lists. This is something which is generally used for cross account permissions for accessing S3. Okay, that's how you define S3 access control lists, ACLs. And then you have session policies, which limit the permissions granted by identity based policies for a specific session. So this becomes more session based, and they work like permission boundaries only. Now quickly, if you want to one liner, if you want to understand permission boundaries, they set the maximum permissions. Okay, service control policies are on the AWS org level. They define the maximum permissions for account members of an organization or organizational unit. So they can restrict even the root user, while normal IAM policies can't. S3 access control lists are more for cross account S3 access. One account trying to access S3 of another account. There you would need S3 ACL to be having permission on that account, for that account to access itself. Okay. Session policies is more about the session. Here we are trying to little bit, I think we already covered this, but let me see if something I should tell you, which is an important point. Permission boundary, we already saw it's a maximum permissions granted to an identity based policy. It's basically, it's like it would limit permissions, but it does not actually grant permissions by itself. It's like a filter. Okay, already permissions are there, you apply some filters to put that boundary. Okay. And then you have SCP, which they operate on the account level, and they limit permissions for entire AWS accounts. Okay, and not only the individual user role, that's the difference. It's on the account level, and it can restrict root user, broad organization control, etc. Okay, so that's pretty much on the two. SCP and permission boundary are sometimes asked as kind of how do you differentiate between the two, so that's how they are different. Identity versus resource based policies, I think we already covered, but yeah, resource based are applied to the resources, identity based policies are applied to the users, roles and groups. That's the major difference. And policy types in identity based could be standalone, inline. Resource based, it is more inline only. Okay, moving towards the IAM policy template, because this sometimes can get confusing. That's how generally the policies are defined as a JSON in AWS. So you can have multiple. So as you see, the statement is an array here. So you will have an array of objects. Okay, so one object containing one set of one statement, and that statement can have one effect, allow or a deny. By principle you mean who is trying to access the resource, who is trying to do the action. Action is the the action, the verb, you are trying to get, put, create, whatever you are doing based on the resource. Putting an object in S3, getting object from S3, getting row from your RDS, creating a row in RDS, whatever. So depending on the action you want to do, you would have the action here. And obviously you can have a star if you want. We all know star generally comprises it's an abbreviation for all, right? So if you give S3 is to all, which means anything on S3 you can do, okay, as an action. And what is resource? Resource is on whom the action is getting performed by the actor. Actor becomes the principal. Okay, so here as a user, if we are talking about identity based policy for a user. So for user Romit, this is the kind of statement you will have. So Romit is having access to get object from my bucket, S3 bucket, on this condition. Okay, so you can put it on a condition based logic as well, and if you don't put condition, then you just have the permission on that resource for that action. Okay, that's the idea. So this becomes a IAM user identity based policy. Okay, now I think this I already covered. Action is, effect is allow, deny. If it is not allow, it is always a deny at the start. Action is what you're trying to do. Principle is who is doing the action. Condition is what are the additional constraints for the policy to be valid. Okay, and resources is on whom the action is getting performed. That's what we have put in this slide. Okay. This is just different parameters of a policy template we are putting here for clarity. SID is nothing but a identifier for that statement, because you can have multiple such statements in that policy, as we saw. So statement 1, a unique identifier SID becomes for statement 1. Then you can put a comma and then an object with similar parameters for another statement in that policy. So it becomes a array of objects, right? If you know JSON, you would understand. Okay, now quickly on how AWS decides access. Before that, let me stop here. If anybody has any questions, I can take that. Otherwise, we can move forward. Okay. So generally how AWS decides access is, it starts off with if allow is present. First of all, allow has to be there, and an explicit deny if it is present. So if explicit deny is present, then you know that you are not going to get the permission. If the credentials are present, if the request is authenticated, then the incoming access attempt. Okay, so that's how the flow works. So you start with first checking if allow is present, if deny is not present, and then if request is authenticated, and then finally the decision. Okay, so it happens like this. The order would be request authenticated, explicit deny, you check, and then if allow is present. So if deny is not present, then you check for allow, and then the final decision. That's what would be the order. Okay. Evaluation logic. Okay, so this again, how just to mention how deny works. So an explicit deny always overrides an allow statement. Okay, so as you can see here, I'll make it a little simpler for you to understand. So here you see the first allow action is EC2 to be terminated on all the EC2s with source IP in that in that CIDR block. Okay, now there is an explicit deny for any EC2 action. Forget about terminate anything, because there is a star, and then any resource, any EC2, there is a deny of any action on any EC2, but with a condition that the deny the region may not be equal to US West 1, which means the deny is not there, is the deny is not present in US West 1, which ultimately helps us in the allow part. So in that way, US West 1 region gets allowed for EC2 termination. That's how the policies evaluation work. So you are denying, but you gave a pass to region US West 1, where the deny won't hold, because you are giving a condition string not equals US West 1, which then allows the first statement to allow EC to terminate on US West 1 with source IP within that CIDR block. So deny to allow, that's how you try to evaluate. Hope this is clear. Okay, we didn't talk much about role. I wanted to cover it a little later, because role, you should know the various different nuances before we talk about role. So generally I take IAM role a little later. So now let's come to the very specific examples where EC2 is trying to access S3. Okay, so when EC2 is trying to access S3, EC2 would need to assume a role, and that role needs to have the permission to access S3 bucket. For same account where resources are in the same account, generally bucket permission separately you don't require for any other service to call or access S3. Okay, that is one thing. So EC2 basically needs two permissions. One, permission to assume the role, and that role itself. Okay, so that's how the trust policies work. And then Lambda accessing DynamoDB. Now what would happen in this scenario is Lambda again would need to have its execution role, which would need to have the permission to access DynamoDB. So permission, it should have permission to assume the role, and then once that permission is there, that role needs to have permission to access the DynamoDB. Okay, and then so Lambda function basically would assume the IAM role, which is generally the IAM execution role, and then through that role, the permissions associated to that role or the policy associated to that role would need to contain read or write whatever you want to do from DynamoDB, and that's how Lambda can access DynamoDB. Similarly with EC2 as well, very similar. Quickly on the cross account access, so there is an account A. This account A wants to access let's say S3 of account B. It could be any other service also. So what again needs to happen is the account A would need to request to assume a cross account role, which is a role in account B. The trust policy in account B should allow the role to be assumed by account A. Okay, once that trust policy is there, then after assuming the cross account role via temporary credentials provided to account A can access the account B's service. Okay, that's the idea. Okay, we talked a little bit about role trust policy and role permission policy. Let's look at it in detail, because this forms a very important part of what we are trying to do. So every IAM role, this is only role specific, remember this, every IAM role has two critical policies. One is the role permission policy, the actual permission policy, and the role trust policy. Okay, so which means who is allowed to assume me. IAM users and IAM groups, they do not have trust policies. Please remember that, that's the major difference. Only roles have trust policies, which basically tells you who is allowed to assume the role. Okay, So role permission policy is, normal permissions related policy which we just saw. With it will have the different statements with principal, resource, action, etc. And then on top of that, the role trust policy should have a permission for that principal to assume that role, for that particular identity to assume that role. Only then the actual role policy will make sense. Okay. So how this flow works, let us check that quickly. So you have a IAM user initiating. As a user, you are logging into the AWS console. You have user policy evaluation. Okay, so let's say that user policy gives you access to invoke Lambda. Okay, now Lambda, when it comes to Lambda needs two things. It would need to assume the role, and an ability, it would need permission to assume the role, and then the actual role permission policy would need to have permission for it to access the whatever resource we are trying to access. So we started with IAM user, then we went to another resource which needed to have both role trust policy and role permission policy to access a third resource like a S3. Okay, that's how this works. Okay, this particular slide will make things very clear what I am talking about from last 5 minutes, specifically with respect to role. So let's consider two scenarios. One, you have an inbound access user or a service. So as a user, you are logging in, or as a service, it could be SNS, S3, SQS, anything, but not compute. So any service apart from compute is trying to access compute. Now, how will this happen? So basically, on compute, you would want an inbound access. Something is incoming. Somebody is trying to access compute, means access Lambda, EC2, ECS, EKS, right? So this would typically require a resource policy at the Lambda's end, at the compute's end, which is answering the core question, who can call me? This will contain, okay, S3 can call me. Whatever is the details, you can put either the specific resource or you can give a star there, which means all the lambdas. If we are talking about Lambda, all the lambdas could be called by a specific S3 or a set of S3, whatever it is, right? Generally it would be a single S3 only, so principal would be singular generally. Okay, then let's talk about the second case. So inbound access, who can call me, is what you need. So which means you need resource based permission or resource policy on Lambda or on EC2 or on ECS, EKS. Outbound access, now compute is trying to access another service. Let's say your Lambda is trying to access another service like a DynamoDB or any other DB, RDS or S3. It could be S3 as well. So in that scenario, you would need the identity policy on that compute. What can I call? This identity policy again would this identity policy would be attached to a execution role here. Okay, because the compute is trying to access another service. So execution role, again, what would execution role contain? This execution role should have permission for this service which is trying to access the other service to assume the role. So first the role assumption and then the actual permission to access that other service, which could be S3, DynamoDB, etc. Okay, so inbound access on compute, you need a resource policy on compute. Outbound access from compute, you need identity policy on compute. Okay, hope this is clear. This, if you are clear with this, you are clear with IAM. Okay, that's what I think. And this again cheat sheet, where I took a list of different permissions which generally service to service permissions are required on a day-to-day basis when you're trying to work with AWS, and this would give you an idea what permissions are required for what kind of access. So let's say Lambda trying to access S3 in the same account. It's an outbound access, we just talked about it. So you need Lambda execution role with whatever action you want to do. Here you don't require a separate bucket policy. Please remember that. In the same account, you don't require a separate bucket policy on S3. Only the incoming policy for Lambda which is there is sufficient. Whatever execution role that policy, whatever is attached to that role is sufficient, providing the access to that S3. Now EC2 to S3, very similar case. Here instead of execution role, we call it the EC2 instance role. Okay, which can have any kind of action, S3 get bucket, put bucket, whatever you want to do. No bucket policy required for the second party, which is S3. S3 cross account access. If some account 1 is trying to access a bucket from account 2, here you require a bucket policy to be defined by the second account on which that access is happening. Let's say you are trying to get or fetch some object from account 2. So on account 2, you would need to have a bucket policy where you will specify, okay, account 1 can access me. Okay, that's the idea. Lambda to SNS. SNS is a simple notification service for basically providing notifications to different services. In AWS you use SNS. So if Lambda is trying to Lambda is trying to access SNS, okay, or call SNS, okay, then you need again Lambda execution role, no topic policy for the same account. So the second resource which is getting accessed in the same account, generally you don't need a specific topic policy for that. So for SNS we call it the topic policy because it's a pub sub model. Generally SNS works in that way, where you have different topics and then different consumers subscribing to that topic. So here Lambda is trying to push to a particular SNS topic, and for that to happen, that execution role, Lambda's execution role needs to have that permission, providing a publish to SNS, which can then be subscribed by other consumers. Okay, and Lambda to SQS, let's understand what, again very similar. Lambda's execution role needs to have a send message. If you are talking about sending a message into the queue, you don't require at the other end queue policy under the same account. So it is behaving very similar to how Lambda behaved with S3 or Lambda with SQS or DynamoDB. Okay, and let's say if we go other way around, if any of the other services like SNS, S3, Event Bridge or API gateways is trying to access Lambda, then you need a Lambda resource policy at the Lambda's end. Okay, so this is the inbound access of compute. So that's why Lambda resource policy. Others were all outbound access from compute. So you saw execution role or EC2 instance role, etc. Okay, coming to SQS, trying to access Lambda, here it's an exception. That's why I have put it here. Here you don't require a identity based policy on SQS, because SQS works little differently. SQS is a queuing mechanism. What happens is the consumer of SQS, whoever is trying to consume from this queue different messages coming, would actually poll in the queue. So Lambda would keep on polling, which means, let's say if the time interval is 5 seconds, every 5 seconds Lambda would try to see or call SQS to see if there are any messages for it to process, okay, or anything on those lines. So here Lambda only is doing the work. It is polling, right? So you need Lambda execution role to have the permission for it to basically poll SQS, okay. If it is S3 to SNS, you need a SNS topic policy, okay, just putting it out. It is basically inbound to SNS. S3 to SQS, you need SQS queue policy, whatever is policy for that resource. And SNS to SQS, that's a very common use case where you have notifications getting sent, and then SQS is one consumer or one subscriber to one of the topics in SNS. This is a very common use case, SNS sending the message to SQS and then SQS processing it in the queue, okay. SQS again downstream can have multiple consumers processing whatever is coming into the queue, okay. So for that you require a SQS queue policy. Any additional nodes, you see push services. So here what these are all the push services. They are pushing SNS, S3, Event Bridge. They are all pushing the data into compute, or pushing basically they are pushing the call into compute. So you need permission on Lambda. Push services, you need permissions on Lambda, which means the Lambda resource policy. Pull services, where the Lambda is pulling from that service or polling from that service, you need permission on Lambda's role, okay. That's typically how it works. Very important slide, I would say one of the most important slides of today. This basically gives you a gist of what actually you would require for you to access whatever resource from be it Lambda to S3 or EC2 to S3 and so on and so forth. So this gives you that idea. Quickly touching on policies associated with S3, and we will stop it after this. I think we are out of time as well. So for you to access resources in S3, first of all, please remember S3 is not a compute service. I already mentioned there are only there are only 3 or 4 compute services in AWS, which are Lambda, EC2. Fargate is nothing but a launch engine, and then you can call it as a compute service, which internally can use ECS or EKS for containerization, okay. So S3 is a resource service. It's a storage service. You are storing some files, some data. It's not a compute service. You are not executing any code in S3. So that's how S3 is a little bit different from Lambda. So S3 would have a S3 bucket policy, which is resource based. Generally this comes into picture in cross account access. We already saw that. For the same account, generally you won't have S3 bucket policy. You would be the resource policy would be sufficient, or not the resource policy, the execution role policy would be sufficient, whoever is trying to access S3. So that is what we are talking in the second point. Identity based policy used by the callers. Whoever is calling S3 you need which is attached, which could be attached to a user role group and used by services like Lambda, EC2, etc. So this would require the S3 access. Okay, so in the same account, bucket policy won't be there, but identity based policy would be required for this user or role to provide permission to access S3. Okay, but S3 bucket policy would be required on when a resource from another account is trying to access S3. Please remember that thing. So generally S3 doesn't use a role. Okay, but I have just put a couple of scenarios when S3 uses a role. These are all far-fetched scenarios, edge scenarios, you can think of it in that way. S3 cross region replication, you just try to put it as a point, no need to go into the depth right now for all this. This is a edge scenario anyway. S3 cross region replication, S3 needs a IAM role. Okay, and S3 batch operations, then there also it uses a role. Okay, this also kind of a cheat sheet I have given. Quickly we will check it out. Lambda to S3 in same account, do you need a bucket policy? No. EC2 to S3? No. Cross account access? Yes. Public website bucket? Okay, obviously if from internet you are trying to access S3, you need the bucket policy to be providing access. And if it's VPC endpoint, restrict by IP, HTTPS, explicit deny, all these require S3 bucket policies. Okay, only internally in the account, another service, if it is trying to access S3, there you don't require, because the the identity policy attached to that resource would already be having that permission attached to it. Okay, so that's why AWS doesn't want a separate explicit bucket policy within the same account. Okay, this is more we can cover this later, but typically I would stop here. Any questions I can take. This is what I wanted to cover, more or less the very major topics we covered today related to IAM. Especially how the policy evaluation logic works, what are the different parameters in a statement, the action, resource, principle, what are the different policies, when we talk about IAM role, which is the role permission policy, the role trust policy, which actually tells you who can assume the role before the role itself getting attached to that resource, and so on so forth. Okay, and plus the cheat sheet which we saw, so that I wanted to cover a little bit in detail, so that it's crystal clear, when one service requires another service's access, what is it that is needed. Okay, hope that was all clear. Next session mostly would be on Monday. That would be on I suppose databases, AWS databases. We will try to cover important topics in DynamoDB, where DynamoDB is one of the most important databases in AWS, and plus RDS and Aurora, which are relational database management systems, which I think most of you would be aware. NoSQL is what generally people don't use that much, but yeah, we will cover all the three majorly, different features in those databases. So hope some of you can join that session as well, and we will try to also do some live workshops, where that would be later on. First I want to cover theory sessions, because without theory you don't understand the basics. Then we will we will take a use case, and then with the help of Copilot we will try to provision resources and see if those resources are getting created on AWS, and we will also see what are the permissions which are getting created, what is the meaning of those uh, of those syntaxes, especially let's say if we are going with Terraform provisioning, then the different resources, it creates, what is the meaning associated to that. So we will look into all those things. Before I go, let me send this link, just a quick feedback. And if you want to join a community we are trying to build, where we will discuss you'll get the updates on what is going on with respect to AWS, and any opportunities arises, we can try to push it into that group. So please provide your feedback in this form. I'm asking feedback about the session, and little bit on your preferences with respect to joining that community, and so on and so forth. Okay, so do provide your responses. This is very much important, because a lot of times people just take the session and then even feedback is not there. So for me, for us to create the credibility, I need the feedback for me to little bit improve. And if you are on the edge whether to give 4 or 5, give a 5 only, that would be better. I mean, if you want to give 4, it's fine, but because what happens is sometimes these things average out, and sometimes let's say I screwed up, so to make up for that one small mistake I may have made, I need some good 5s. Okay, so so hope you understand what I'm getting at, and we don't want to unnecessarily ruin the group's ratings, right? Because obviously, I mean, I know that I'm trying to do my level best. I have other things to do, but I'm doing it as since I like doing it, so I'm doing it, and it could be good. So it takes time for us to build the community, but let's see how it goes. Yeah. At this point, sharing presentation won't be possible, Rahul. But we'll see. You attend the other sessions. That there is a reason why I'm not sharing the presentation, so that people don't just sit on a sofa and take this session. If you are doing that, you won't get much out of the session. I'm thinking or assuming that you are having your own notes. At least you are noting a few important points down, and so, because a lot of these points are from my own notes when I was preparing for the certifications. I took some notes while preparing, and I have tried to put a few of those notes points into the slides. Okay, because that made it easy for me to understand. So hopefully you are trying to take the notes of the important points which are discussed. Okay, let me see how many of you have actually provided me the output, the feedback. 1 second. So today I think there is only only one person has actually submitted the form. I don't know why is that. Because I mean, we are not forcing anybody to join the community, or you can simply say that you are not interested. Okay, few people have already submitted, which is fine, but I think I see few new people as well. So before going, just submit that, and I'll see you on Monday or Tuesday, whenever we do that session. Mostly it will be Monday, the database one. Thank you, guys. I'll still not end the video. We will keep it if anybody is still submitting the feedback. I'll give it like 15-20 seconds more, and then we'll wrap up. Thank you, guys. See you next time. Bye.